In this video, we're going to look at the basic operations we could perform with the slot table. The slot table provides us with an internal API, which is a builder, and it takes in an instance of a slot table address space. What this does internally underneath the hood is that it creates a page with 64 empty slots. This is called a group address space. This is an example of creating a group in this page. I'm creating a group with an arbitrary key value of 37. And what this does is that it adds a group in the first offset of 0 with the key of 37. A group has an address, which is a hex value of 0. As I start to add more and more groups, they get added linearly like this. When the page gets filled up, another page is created for me in which groups are added, and they get linked together like this. How do I go about adding metadata information? Metadata that I would want to add is like, what is the child of a group? Here's an example of creating a child of the group with key value of 37. So I have a child with a key value of 38, and it gets added to the page, the group address space like this linearly. In the page offset 1, I have group with an address of 1 with a key of 38. So each group has metadata which looks like this. It has basically a reference to what the parent is and what the child is, and these are the group address values. I may also want to add in primitive values. For example, I have a sample composable method. The compose runtime underneath the hood creates a restart group for this, and it stores in the primitive slot space the computed value of the variable a. How do I store primitive values? It looks like this. I'm using the append method, and I'm storing the value of 1. And what this does underneath the hood is that it will basically create an empty page. This is different than the group address space. And what it will do in this page is that it's going to store the primitive values for each of the groups. So it's going to store at offset 0 the value of 1, and it stores for which group it belongs to, the group address, which in this case is 0. If I store more primitive values, they get added linearly, one from the top to the bottom like this. So I have a value of 2, which is also for group 0. If I want to store more primitive values, in this case for this child group of 3, they all share the same primitive slot space. So they all share the same primitive slot space, and all the primitive values gets stored here one by one. In this case, the value 3 is stored for the group 1. So this is what the metadata looks like so far. I have primitives in the primitive slots. I have a value of 1 stored in the group at offset 0. I may also want to store reference types, such as a string. So for example, suppose the sample composable, I want to store the computed value string. How do I do that? I'm using the same append method, and I'm passing in a reference value, for example, a string, in this case starting. And this will also create its own reference slot space and will store values from top to the bottom. In this case, I'm starting from the top at offset 0 and storing for group 0 the value starting. And in the end, my metadata looks like this. I have things stored in my primitive slots and my reference slots. And these reference and primitive slots are shared. That's important to know. So how do I read groups from the top to the bottom? This is important for recomposition, where I need to traverse the group hierarchy. So there's a method called read on the slots variable. And what it does is that inside of this, I could use methods like start group, which specifies the starting. And then suppose I wanted to read the group key of the second group of 1. And I could do a println like this, and I could get information like the group key and other information like the flags that it has. And so this is nested behind these markers, start group and end group. I could also skip that group by using the script group method, and this is useful, for example, in recompositions. Now skipping the first group, I could go to the second group and print this group key, which is 39, for example. So that's how I read groups and skip them from the top to the bottom. So when you're playing around with the when you're playing around in the Compose Runtime source code in the Android open source project, you could look at the hierarchy by using this internal method, which is useful when you're learning about the slot table. It's called toHierarchyDebugString, and what it does is that it prints information like this. As you can see, this group has a group address of 0, and it's at page 0 and page number 0, page offset 0. It has a hex value of 25, which is in decimal 37, and what it also contains are group flags that we'll look at later on the next video. And it has, for example, it's reference slots, and you can see the primitive slots in there. So that's really useful. And if you want to learn more about Compose and Kotlin and coroutines, check out my website at codingwithmohit.com.